Yes, thank you very much. My name is Jesper Hoffstedt and I'm an associate at We Are Movement. Really nice to be here, by the way. And I'm going to talk about my experiences from working as an SPC at Scania. I've been there actually for 3.5 years, working with huge products like this. We currently have 11 large solution trains and 85 agile release trains. So it's fairly big, and it's both software and hardware. And I've been focusing on the electrification and e-mobility parts. So by the way, this lovely product, how do you know if it's electrical? Helena, you're from Scania, do you know that? You're working with other parts. But it's actually this blue thing here. I think it's quite nice when you're out on the streets. Look for that one, then it's electrical. Okay, so what I have been tackling during my 3.5 years is the usual comment that we get really often. This doesn't work from hardware. It comes from the software industry but doesn't work to us. And I've been tackling that question a lot, and I've been better and better to answer it, and I've found new narratives and models on how to talk about this. So my strong belief is that working agile with hardware is really, it's nothing new. It's basically the same principles and so on, but very similar. But the thing you have to do as an SPC is to change the way that you're describing things to get buy-in from the engineers and from middle management. And that's what I'm going to talk about. So it's a bit of a smorgasbord and a mixture of reflections and learnings from this. And the first one is if you talk to the real upper management, then of course time to market and flexibility is really key. But when you get to the engineers and middle management, there is a tendency that they feel it's impossible. We cannot be faster. We cannot deliver within a planning interval, for instance. This takes too much time. And the end goal, of course, is to increase the speed of delivery, but it's much better in a hardware context to talk about speed of learning. There is typically it's quite common as well that agile is misinterpreted as quick and dirty. I've seen quite a few examples where it's like, okay, we're skipping 1 year of testing to reach the customer really quickly, and we all know that that's a recipe for getting slower because the technical depths becomes really big. So I always talk about speed of learning, which will of course lead us to improved time to market and quality and flexibility. So I've been using this picture a lot. I guess you all recognize it from Leading Safe, for instance, although I made my own graphics. And it's about set-based design. And I use this one when we talk about, okay, how can we fit things into 2 weeks or 10 weeks? And specifically, this is about the 10-week interval. And then instead of getting into like, oh, you need to define a user story where you deliver and customer value in one sprint, that communication doesn't work if you start at a place like this talking to hardware engineers. So we need to find another language, and then talking about exploration features, where when the question comes, okay, where are we, how do we slice things? Look at it this way, we are learning in the cone of uncertainty, and the question is not, to start with, it's not about delivering customer value, it's about delivering learnings, and the value of learnings is quite big, which will in turn, of course, all the time it would lead us to customer value. But this is a way of looking at it that works much better in this context. So then, slicing of features is usually, that's where we find the big problems. when we are going to look at it. How can we? The lead times are so long, so it's basically, it's impossible to do it. And then again, the best question that we can ask is, what can we learn with the parts we have today? Because it's so common when I meet the engineers, and quite often hear, yeah, it's impossible to break into 10 weeks because the lead times are 20 weeks, so it just doesn't work. And then I start to ask them, and I become better and better at asking them and finding, okay, how can we change things slightly, making sure that we deliver learning value early on? And then I quite often find that the engineers tend to wait for the complete product, or all parts have been delivered from the vendor before they want to test things. But very often it's easy to 3D print parts of it, or as we say here, what can we use the parts we have today? So we have, if we're going to test just the chemistry of a battery cell, then maybe we don't need to test it with a new battery pack. We could use an old one that we could take from an old truck, for instance. And so what do these learning features look like? And here's just an example where we are learning and exploring the strength of a drive shaft. So we're going to design a drive shaft. We could even do it in different materials, and we want to learn when it breaks and when it doesn't break. So this is a typical example of a learning feature where we create a limit graph and we get a lot of data that we could actually feed into our simulation models, which would make the simulation models even better, which would give other advantages as well that I will get to in a little while. Questions and comments are welcome along the way, so don't hesitate. And then, how do we learn fast? Make friends to learn fast. I mean, it's quite obvious as coaches, but to me it's been really interesting journey, because I'm not a mechanical engineer, so this field is completely new to me. And compared to when working with software, that's kind of my home domain. But right now I'm entering that, okay, I'm an okay SPC, but I don't know anything about mechanical engineering. So really humble people, those engineers, and they love to talk about the product. So just talk and be interested and curious about their product, and you will get so far together. And so that's been really fun journey here, I would say. And now to a bit more complex picture on how can we, I mean, in software we talk a lot about shifting left, test first, unit testing and so on, and how can we translate that to the hardware world. And here I've used, this is actually a picture from Safe for Hardware training that I've used to explain how we can think about shifting left. So this example fits very well into Scania as well, but in this case it is a rocket, and we usually have different levels of components and modules and subsystems. So here it's just the nozzle part of the engine, and then we have the engine and we integrate it to a rocket. And that's done in different environments, meaning that we start out working in a digital environment where we can simulate and have much faster feedback loops. And then go into physical prototyping, manufacturing and scaling it up, and to the operational environment where the end customer is actually using it broadly. And what I've added here is that to look at it, if we go vertical, then we're integrating and we're slicing things value-based to look at the complete product. And the other angle is about industrializing, so getting closer to the industrialization. And these are both options when thinking about slicing. It could be a really good thing to slice things vertical to learn about the complete product, but it's not wrong to slice it horizontal either, to learn about the production and really fast learn about, okay, this might be a better design because it's easier and cheaper to produce it. So if we look at these two angles and the environments, we find a lot of learnings. So again, we're back to learning things. And up here, we could learn a lot about the product and the technical parts itself. How can we simulate? Simulating it, making sure it works early on. And then, of course, in the operational environment, that's where we learn the most from a complete mass of customers. And then down to the right, we learn about the manufacturing. So we have a lot of different feedback angles here. So there's a lot of opportunity for learning, and we could use this when we are slicing things into smaller parts, because we can ask ourselves, okay, can we learn in that direction or in that direction? And the good thing here is that shifting left, we want to learn as fast as possible. And to learn as fast as possible, we need well-defined interfaces, so we can unit test our units. And then we're doing integration tests, but still in a fast virtual environment. And to do this shift, we need to feed the simulation model with data. And constantly, when we're doing prototyping and we also have the products at the customers, we get a lot of data that will be fed into the simulation model that's really shifting all testing left. So we could test more and more and more in a simulation model. And this is a shift in the way of thinking, but also in culture, because most engineers I meet, they really want to try this on the complete physical product, which probably is not strange, but we'd like to drive more testing to an earlier stage, although they would see it finally, and we need to test it on the complete product as well in the end. So that was a little about on thinking how we could slice things and talk about learning. And of course, learning gives us also, that's the way to tackle like quality issues. I mean, we might have a lot of quality issues. Okay, if we would have learned earlier on, then we would have found them earlier. And also regarding typical really tight deadlines. I mean, yes, we could make the perfect plan, but what about trying to break the timeline or really try out the hardest things first, making sure that we learn about the timeline in this specific delivery. Okay, so we move on to the typical product development process that most cyber-physical companies and software companies, of course, as well have. And the way that I've chosen to see this PD process in this case is to look at it as the continuous delivery pipeline, because that's how we get to production. But it needs to be adjusted and changed to a more agile way of working. But there's a lot of knowledge and quality built into this process, so we can't just rip it out, but we need to change it gradually and look at it with agile glasses. So starting, and this is also a bit, it's about explaining and talking about things. Of course, we are doing these things, we're starting trains, creating cross-functional teams, financing capacity and so on. But why do we do that? And what are the arguments? I mean, we'd like to, from this PD process, we'd like to remove the handovers, because it's quite designed today to handle handovers between different departments. So we need to change it and remove those handovers. And we need to optimize it for fast learning. Today it's not allowed to enter a milestone before we have done a lot of things, which means it delays the learnings. And there are also very big decision points where we need to take to be allowed to start producing this. We must have the complete scale up of this product for the 5 coming years and which markets and so on. And then no one dares to take those decisions to release things. Or maybe we dare, but we don't really feel that responsibility because it's kind of really hard to tell. And then I think that one of the main problems is that this product delivery process is really tight connected to projects. So everything, I've been asking quite a few times, okay, but this product development process, is it also a project steering model? And the answer is usually no, it's not. But when you look at the milestones and the definition, it's projects all over the place. So that's a big challenge, and I think it could remain there, but we need to get the projects out and get the arts and their deliveries into the process. And of course it's fairly sequential, and a bit harder thing to do here is to make it work in parallel, making sure that we could work more in this horizontal line where we start to meet production and service markets and so on earlier on. And then another challenge that is really different from software is that the deployment takes so much time. This is the industrialization part, where we actually can do exploration and integration, and we could have a really, really good solution here that works at our end customers. And that could be like a one-off prototype, and there are big companies using these out in the field today. But then to industrialize this thing and build the factory basically that can deliver this in scale takes so much time. So this is a hassle. How can we learn to work with industrialization in a faster way? And that's about investing in the factory, but also in the continuous delivery pipeline. For instance, getting this simulation data in to our models. And I think the real challenge here is to do this for large changes in the product. At Scania, we are really good at actually doing continuous changes very close to the production line. But these are small ones. When we scale it up, it's still buying a new machine and designing new factories completely, and then it takes a lot of time. When talking to the teams, it's quite fun because coming from a software background, we all know that we share the code, and it's not your code and your code, it's our collective code together. And we work with our common backlogs where we share work. Talking to the engineers, it's really common that they have their CAD models, and they are really privately owned. It's my CAD model. I usually don't show it to too many people until I'm done, and I have my own security checks and quality things in my model. And does that sound familiar? I think, yeah, we saw that. We probably see it today as well, but it really feels like 15 years ago in the software industry to me. So there is huge potential in helping these teams to pair and mob in some cases, but just asking them to, could you pair for 2 hours a week? And usually I attend there as well to be the naive and not understanding that much about the product, because we get good discussions, as we all know. So that's a really fun thing. And then since it's a huge product, we tend to have the problem, okay, who is the customer? And I'm going to write the user story that defines the delivery to the end customer, which can happen that it's possible, but usually quite rare. And then I use this model to get out of that discussion and really encouraging people to have multiple horizons of a perspective on the customer. Meaning that the lean definition, whoever consumes your work, that's your customer. Maybe the one integrating the batteries in the chassis. And then there is the end customer, maybe the one that buys the truck or that drives the truck. And then there's also an end user who might be the one eating the bananas that was delivered by the truck. And this helps solve the problem with teams building components far away from the end customer. So that's been a good way of talking about it. And then I've seen another reflection is that these companies are usually really good at firefighting, and they are used to solve urgent problems. And then they usually create a task force. And a task force, that's like an agile team, because suddenly it's prioritized. Okay? Sounds familiar. And it's cross-functional. Okay, sounds familiar. And they have all the resources they need available. So they have the test rigs there, they have the production people there, they work together close to the product. So that's where we have really good examples, and this becomes a bit special to advocate for, because we have agile release trains that works with everything simultaneously and no prioritizations. And then we also have these task force teams. And the comment is usually, yeah, but these task force teams, they destroy for everyone else because they get prior. Yeah, they get prior. So probably it would be possible to reduce the amount of simultaneous work with half. And then suddenly we could have 20 task force teams in our agile release train rather than all around the place. Yeah, and as well, I mean, handling any argument regarding that it only works for hardware. Let's see. Working good. I mean, we see the same challenges here as we saw 20 years ago in software. It is hard to test. Yes, it was hard to test software as well. We have so many specialists that are the bottlenecks and no one can do their work. Similar thing. It's really hard and expensive to release. We have long checklists in our review boards and complicated cross-dependencies and everything like that. And it's the same here. And it's possible to solve it, but of course we need to invest in our test environments and in our continuous delivery pipeline to build quality and speed into the system. But it's quite easy to talk about it in this way, and suddenly you realize, yeah, it's the same problems, and it should be possible to solve most of them by working in a more lean agile way. Then there are, of course, a lot of assumptions built into the walls in big successful companies that have been running for over 100 years. Like, yeah, our lead times are 20 weeks. We cannot change that. And I find it's usually quite fun to talk with, specifically the progressive architects that are really, they like this. And then I usually talk about, okay, how can we remove our assumptions? And one way of doing this is an example where we have a firefighter from the Second World War, where they were looking in UK at, okay, all our firefighters getting home to UK, where have they been hit? And they thought, okay, let's strengthen the construction where they have been hit. And then someone said, well, maybe it's the other way around, that the planes that didn't come back, they were hit here, so that's where it's important. So really challenge the truth that are built in the walls. And also when slicing, when discussing how to solve this, make sure we get all different perspectives and input so that we could think differently. And one of my favorite principles from the Agile Manifesto is the simplicity. the art of maximizing the amount of work not done. So how can we do less? And then I think this is a wonderful hardware example where the problem is that we'd like to learn our kids to bicycle, and then we design a product for that which adds things. It adds the balance functionality in this case, and then it took like 20 or 25 years to come up with a simpler and better solution. Can we remove something? Yeah, remove the propulsion, that's the hard part. And suddenly the kids learned to bicycle faster, and it was cheaper training cycles as well. And I think this is also about agility that we can use. It's a way of thinking that also needs to go into this system to challenge. And then finishing off with a quote from Elko Rustenberg, that engineers deserve to get back to their natural way of working, less hampered by organizational gravity. And you can really see organizational gravity is a problem. And the engineers think it's really fun when you're talking about their product and doing prototyping and being close to the floor and so on. So that's also a way of selling this to the people doing the work.